Hello friends. In continuation to my previous lecture on set theory, basic concepts and definitions, in this lecture I am going to discuss further few more definitions. The first definition is complement of a set. Let A be any set, then the complement of A is defined as A complement is equal to curly bracket starts X belongs to U here stands for universal set. Already I told you in my previous lecture, such that X does not belongs to A. A कॉम्प्लीमेंट में वो एलिमेंट्स आएंगे जो ए को बिलोंग ना करते हो बट वो यूनिवर्सल सेट को बिलोंग करते हो. सपोज हमने एक यूनिवर्सल सेट यहाँ पे कंसीडर कर लिया से 1, 2, 3, 4, 5 एंड ए हमारे पास कोई भी उसका एक सबसेट है 1, 2. इन दैट केस ए कॉम्प्लीमेंट विल बी गिवन बाय 3, 4, 5. सो वी यू ऑलरेडी सीन दैट कि हमने यहाँ से 1, 2 को बाहर निकाल दिया एंड ओनली that elements are considered जो सिर्फ U को belong कर रहे हैं. So next definition is difference of two set. Let A and B be any two set, then difference between A and B is defined as A minus B is equal to curly bracket start X belongs to U such that X belongs to A and X does not belongs to B. All those elements, first of all, they must belong to the universal set, and secondly, with two subsets we are considering, then A minus B stands for X should belongs to A, but it does not belong to B. It is the same phenomena that we have seen in our childhood. Suppose you have 10 chocolates, and if you have given 4 chocolates to your friend, then how many chocolates you are left with? 6. So when you count your number of chocolates, you are not going to count that particular 4 chocolates that you already had given. So in the same way, if we have two sets, say A and B, for example, 1, 2, 3, 4, and B is equal to 1, 2, then A minus B means only those elements will remain जो सिर्फ A के पास है, B के पास नहीं. That is, अब B के पास क्या था? 1, 2 था और A के पास क्या है? 1, 2, 3, 4, 5. So A minus B will give us 3, 4, 5. लास्ट अभी एग्जांपल हमने देखी यहाँ पे कॉम्प्लीमेंट की. इन कॉम्प्लीमेंट व्हाट वी हैव सीन दैट कि हमने ए कॉम्प्लीमेंट में वो एलिमेंट्स लिए जो ए को बिलोंग ना करते हो बट वो यूनिवर्सल सेट को बिलोंग करते हो. तो सम टाइम इंस्टेड ऑफ राइटिंग ए कॉम्प्लीमेंट वी कैन आल्सो राइट यू माइनस ए. दैट मीन्स कि हमने यूनिवर्सल सेट में से ए के एलिमेंट्स को क्या कर दिया? माइनस कर दिया. द नेक्स्ट डेफिनेशन इज सिमेट्रिक डिफरेंस बिटवीन टू सेट. In order to find out, जो ऊपर हमने find out किया सिर्फ difference था. In order to find out the symmetric difference between any two set, the formula will become A delta B is equal to, हमें दोनों differences find out करने हैं, A minus B as well as B minus A. A minus B में क्या होगा? Only A वाले elements रह जाएंगे. B minus A में क्या होगा? Only B वाले elements रह जाएंगे. और उनकी आपस में क्या ले लेनी है? Union ले लेनी है. And then we will have symmetric difference of two set. Next definition is disjoint set. If A and B are any two set, then they are said to be disjoint if A intersection B is equal to 5. That means if the intersection of any two set, any 2 set, any 3 set, any 4 set or any n set, जितने भी सेट आप यहाँ पे कंसिडर कर रहे हो, if their intersection comes out to be empty, then that particular sets are known as a disjoint set. Disjoint, the name itself conveys the meaning कि जो joint नहीं है आपस में. इसका मतलब है कि उनके बीच में कोई भी common part नहीं है. For example, if A is equal to 3, 4, 5 and B is equal to 1, 2, then A intersection B is equal to 5 because we are seeing that कि A के पास क्या है 3, 4, 5, B के पास क्या है 1, 2, nothing common between them, so their intersection is empty, and if their intersection is empty then that particular set is known as a disjoint set. The next definition is mutually disjoint or pairwise disjoint. So mutually disjoint or pairwise, again pairwise means when we are taking some pair. So if consider some collection of set, suppose we have in previous definition I already told you intersection doesn't mean only two set we can consider 2, 3, 4 and n number of set. Suppose we are taking the collection of set a1 to an, then they are said to be mutually disjoint. when AI intersection AJ is equal to I, 5 for all the I and J with the condition that I is not equal to J. That means we are considering any two members from this collection. So we are taking two pair, that is why it is known as a pairwise disjoint. So considering any two members from this collection, then that particular elements intersection will come out to be empty, then in that case we can say that they are pairwise disjoint. The next definition is partition of a set. So again, we are considering a collection of set A1, A2 and so on An. Then that particular collection is called partition of a set if number one condition is that कि their intersection are mutually disjoint. अभी हमने previous definition पढ़ी mutually disjoint के ऊपर कि we are considering, if we consider any two set and if intersection of that particular two set is empty, then we can say that they are mutually or they are pairwise disjoint. So from this collection, that collection can goes up to n. So from this collection, we are considering any two elements. If that two elements are empty, intersection of that two elements are empty, then they are mutually disjoint. And second condition here is that when we take the union of that particular set, मतलब जो जितनी भी collection we are considering there, if we are taking the union of that particular elements, then वो union will be equal to whole set के बराबर आएगी. तो इन दैट केस फॉर एग्जांपल आप देख सकते हो यहाँ पे सपोज वी आर कंसिडरिंग अ पार्टीशन, जेड का पार्टीशन लिया मैंने यहाँ पे, दिस इज सपोज A1, A2 and A3. So here A1 intersection A2 is empty, A2 intersection A3 is empty because -1 and so on, so on, so on up to minus infinity they are going, and here from 1 to up to positive infinity they are going, and here 0. So we are considering three set here. So from these three set, if we are taking any two pair, then that pair is empty, and when we are taking the union of all these threes, that come out to be Z. So if this particular set, this particular collection is called a partition of a set. Now further, we are going to discuss various laws on algebra of sets. I hope जो definition part है, it will be clear to you. Now further, मैं जितने भी laws हैं set theory के ऊपर वो आपसे discuss करने जा रही हूँ. The first law is commutative law. So for any two set A and B, A union B is equal to B union A. This already we discussed in our childhood. We have seen that under addition and under multiplication, the commutativity hold. Either we take 3 plus 2 or we take 2 plus 3, the result will remain same. It doesn't make any difference. Either we multiply 2 into 3 or we take 3 into 2, we are getting the same result. So in set theory, union basically represents the addition and intersection basically represents the multiplication. So in a same way, either we take A union B or we take B union A, the result in both the cases will remain same. Now we have to show that A union B is equal to B union A. So in last video lecture we discussed about the concept equal set, and we know that कोई भी दो सेट जो है वो इक्वल तभी कहलाएंगे जब उनके अंदर सेम नंबर एज वेल एज सेम वैल्यू के जो सेट है, न्यूमरल वैल्यू उनकी क्या होनी चाहिए, सेम होनी चाहिए. ओनली देन हम उन दो सेट को क्या कह सकते हैं, इक्वल सेट कह सकते हैं. इफ यू वांट टू सी, यू कैन गो टू आवर फर्स्ट वीडियो लेक्चर ऑन सेट थ्योरी. सो हियर if I want to show that A union B is equal to B union A, then in that particular case दोनों के elements जो हैं वो क्या होने चाहिए, पहला उनका नंबर सेम होना चाहिए, दूसरा उनका न्यूमरल वैल्यू भी क्या होना चाहिए, सेम होना चाहिए. So here I considering any arbitrary element x that is belonging to A union B. If x is belonging to A union B, then according to the definition of union of two set, x belongs to A or x belongs to B. And it can also be written as x belongs to B or x belongs to A, or it can also be written as x belongs to B union A. So we have seen that कि जो element हमने x लिया था जो A union B को belong कर रहा था, that is also belonging to B union A. So in this case, either A union B is a subset of B union A or A union B is equal to B union A. For that we will consider the vice versa relation. That is why I am using if and only if symbol here. So I am not showing it separately. So if and only if means if I am taking X belongs to B union A, then that means X belongs to B or X belongs to A, and it can be written as X belongs to A or X belongs to B, or I can say that X belongs to A union B. Thus from this whole, what we will see that A union B is equal to B union A. Similarly, by the definition of principle of duality, we can show that A intersection B is equal to B intersection A. The next law is associative law. For any three finite set A, B and C, A union B union C is equal to A union B union C. This is again the same phenomena. That is, suppose if I take any three terms, 3, 2 and 5. So 3 plus 2 gives 5, then 5 plus 5 gives 10. In other way around, अगर मैं इसे order को change कर देती हूँ and I will add something like this, 2 plus 5, but I will get 7. रह कौन गया 3, and when I add 7 plus 3, what I will get 10. So the result in both the cases will remain same and order doesn't matter. So in associative law is the same thing कि A union B union C लिया जाए या A union B union C लिया जाए, the answer will remain same. The same result hold for multiplication as well as intersection. So here again I am taking the concept of equal set definition. So X belongs to A union B union C implies X belongs to A union B or X belongs to C. If and only if X belongs to A or X belongs to B or X belongs to C, and it can also be written as X belongs to A union B union C, and thus we see that A union B union C is equal to A union B union C. Similarly, by principle of duality, we can show that this associativity hold under intersection also. The next law is idempotent law. Idempotent law is basically sort of reflexive relation. जब हम अपने आप से ही किसी relation को justify करते हैं, तो here we are considering only one set, that is A, and we are taking both the relation with A. So A union A will be equal to A and A intersection A will be equal to A. Again, the concept will remain same, the procedure will remain same. Here I take X belongs to A union A if and only if X belongs to A or X belongs to A, and understood if it is belonging to A in both the cases, then that means it is understood X belongs to A, and vice versa this result also hold. So we can say that A union A is equal to A, and similarly we can show that A intersection A is equal to A. The next law is distributive law. For any three finite set A, B and C, A union B intersection C is equal to A union B intersection A union C, or A intersection B union C is equal to A intersection B union A intersection C. Again, by the concept of equal set, हमने यहाँ पे एक एलिमेंट लिया है x जो बिलोंग कर रहा है किसको, A union B intersection C को. If x is belonging A union B intersection C, then that means either x is belonging to A or x is belonging to B intersection C. Now x belonging to B intersection C implies what? X belongs to B and x belongs to C, or separating it, we can write it as x belongs to A or x belongs to B and x belongs to A or x belongs to C if and only if x belongs to A union B intersection x belongs to A union C, and if and only if x belongs to A union B intersection A union C. Thus we see that A union B intersection C is equal to A union B intersection A union C, and similarly we can show the other way around. A intersection B union C is equal to A intersection B union A intersection C. Thus union and intersection are distributive over union and intersection respectively. Thank you for watching my video. Further laws will be discussed in my next video. Please do watch. Thank you.